All right. All right, guys. Well, tonight we're going to work on the law of sines. So basically, why would you need a law of sines? Well, if you have a triangle that's not a right triangle and you try to find out like what the angles are and what the sides are, the way we've been doing trigonometry only works for right triangles. So we have now the law of sines, which will work for any triangle. So basically, the law of sines says that the sine of A over A, so the capital A's are angles and the small letters are side lengths. So the sine of A over A equals the sine of B over B equals the sine of C over C. I'm going to do like a really quick proof about it just so you can kind of see how it works instead of just like have it magically appear. But that is what the law of sines is. And just as a reminder, if you add up all the angles of a triangle, it always equals 180 degrees. So let's take a look at this. So if I want to show you how the law of sines comes into being, basically, hold on, let's use red. So basically, let's say I have this triangle here, and I want to find the sine of A. So notice that the original triangle is not a right triangle. But if I put that pink line down the center, and it doesn't have to be equilateral, even though this looks equilateral, it could be any triangle. So like for example, if I had a triangle that went like this, that's still a triangle, right? And if I wanted to make a right triangle, now this is a right triangle on both sides, right? So it doesn't have to be as pretty as that triangle. So if I wanted to find the sine of A using this triangle, the one up on top, what would the sine of A equal?
That would be the opposite over the hypotenuse.
Exactly. So for this one,
H over C.
H over C, exactly. And then if I wanted to find the sine of C, it's going to be H over A, right?
Mm-hmm.
Okay, so now, but they have the same heights for sure. So if I solve both of these for H, then I'll get H equals C sine of A. My thing is lagging. Hold on, let me see if I can close up something and have it go a little faster. Okay, let's see if that works. And then I can also say here that H equals A sine C, right?
Mm-hmm.
And since the H's are the same, I can set sine of A, C sine of A equal to A sine of C. I'm definitely lagging here. Hold on a second. Let me see what else I can close. Maybe my computer's just about to die. Hold on. I think I lost it. Oh no, there's my mouse. Okay. Huh. Why did I lose my pen? Okay, I've definitely lost my pen. Hold on. I'm just trying to figure out how to fix this real quick.
Oh, you're good.
Yeah, definitely something's wrong here. So let me stop sharing. I think what I might have to do is reset my computer. Can you still hear me?
Yeah.
Okay, hold on. Let's see if stop sharing. Let me reshare and see if that fixes it. Let's see. Oh, good. Okay, that was way easier. So C sine of A is equal to A sine of C because both of these have the same H, right? So I could set the others equal to each other. And then, well, I can divide both of these fractions by AC. And the reason I'm doing that is because here I'm going to cancel my C's and here I'm going to cancel my A's. And notice what I end up with is the sine of A over A is equal to the sine of C over C. And if I, did two different angles, I would be able to show I would be able to show you what the exact law of sines, which is sine A over A equals sine of B over B equals sine of C over C. So that's basically why, okay?
Mhm.
Does that all make sense?
Yes.
Okay, good. So I want to solve a triangle, and when I draw a triangle, it doesn't really matter what it looks like, okay? But there are certain things that do matter. For example, if I label this A, B, and C, and I can label A, B, and C anywhere I like, but if I label it like that, then the side A is always across from angle A, and side B is always got to be across from angle B, and side C has always got to be across from angle C. That is very important, or else it wouldn't work. Okay, so now they're giving me that this is 40 degrees, and this is 60 degrees, and this is equal to 4. So I can add up 40 and 60 and get 100. And since all my angles together have to add up to 180, I now know that this is 80 degrees, okay?
Mhm.
Now, once I have all my angles, the law of sines is very straightforward. So here, I'm going to have to use A because I have sine of A over A, and that's the only one that I have both variables. So I'm going to start by saying that the sine of A over A is equal to, and then it doesn't really matter. Let's just say the sine of B over B. Okay. And so here we go. Sine of A, so sine of 40 degrees. And this is obviously a calculator problem because I don't know what the sine of 40 degrees is, and I don't expect anybody does, equals the sine of 60 degrees, which we do know, over B. So if I want to solve for B, I can say B is equal to 4 sine of 60 degrees over sine of 40 degrees. Basically, I'm almost cross multiplying, but really just multiplying both sides by 4 and then both sides by B, and then dividing both sides by sine of 40. So now I know what B equals. Let me get my calculator. And again, now we're in degrees. And the last time I used my calculator, we were in radians. So really always check. So I have, well, I know the sine of 60 degrees is I know what that is, right? That's the square root of 3 over 2.
Right.
Okay. So all I really need to know, what is the sine of 40 degrees, which is 0.643-ish. So so that's really 2 times the square root of 3 divided by 0.643. And I get that B is equal to approximately 5.39. Now, how do I know if this seems kind of correct? Well, I know that the side across from any angle is going to be really proportional to the angle in a way. So because A is the smallest angle, this side across from A should be the smallest side. So the next smallest angle is 60 degrees. So that's good that this is bigger than A. So I feel like I'm on the right track. If it was smaller, I could tell I made a mistake somewhere, right?
Mhm.
And then again, the same thing, I just really have to do again. So I can say the sine, because I have A, B, I just need C. So the sine of C, and C is 80 degrees over C is equal, and I'll just go back to A because it's nice and easy. So sine of A, which is 40 degrees over A, which is 4. So C is going to equal 4 times the sine of 80 degrees over the sine of 40 degrees. And again, I have to use my calculator because I don't know any of those. So I have 80 degrees. So the sine of 80 degrees times 4 divided by sine of that. And I get, for this one, I get 6.13. So that would give me 6.13. And again, I'm very happy to see that it's bigger than A and B because it should be. So I've actually solved this triangle. I know A, B, and C. So I know all my angles. And now I know all my sides. And that's really all there is to the very basic law of sines. So if you're given 2 angles, you always can get the third angle. And once you have all 3 angles, it's very simple to just do. I don't know why that happened. Okay. It's very simple to just solve for these other variables. Do you agree?
Yes.
Okay, good. Because I don't want to do a lot of these. I mean, I don't mind doing one more, but the harder ones are the ones where you're only given 1 angle, because then you don't have all 3 angles. But
Correct.
again, here we have 2 angles. So I know my third angle is going to be 180 minus 50. So it's going to be 130 degrees, right? So again, I do the exact same thing. I'll just do another example just for the heck of it. So I'll call this A, I'll call this B, I'll call this C. That means this is C, this is A, and this is B. So this is obviously not to scale. This is 130 degrees. This is 35 degrees. And this is 15 degrees. And I know C equals 5. So again, I just do exactly the same thing. So I know everything about C. So I'm going to always start with the thing, the sign that I know the variables of. So I'm going to start with sine of C over C. And then it doesn't really matter what else I use. So I'll do A over A. So again, I get the sine of 130 degrees over 5 is equal to the sine of 35 degrees over A. Solving for A, I get 5 sine of 35 degrees divided by the sine of 130 degrees. And that gives me so does that make sense? So I get A equals 3.74 and C, yeah, A is smaller. Okay, so let's say it is true. Okay, and then again, so this is one set of values. And then I can do the same exact thing for B. So I have the sine of C. I'll just write it out. Over C equals the sine of B over B. So again, I have the sine of 130 degrees divided by 5 is equal to the sine of 15 degrees over B. And that means that B is going to equal 5 sine of 15 degrees divided by the sine of 130 degrees. And let's see, we get 15 sine. So I get for B 1.69. So this is 1.69. And again, do I know the numbers are correct? I don't know. I could have made a mistake, but I know that they make sense because the smallest side is across. Surveyor takes 2 sightings at the peak of the peak at a distance of 900 meters apart. So between these two are 900 meters. So I know that side of the triangle. The first observation results in an angle of elevation of 47 degrees, which we can see is right here. And the second results in 35 degrees, which is right here. If the transit, basically what that means is, if you notice, this is the bottom of the mountain, but it's going down. So they're saying that the transit is 2 meters high. So at the end, we just want to add these 2 meters in because those aren't taken into consideration with the triangle that's shown. Do you see that?
Mhm.
Okay. And what is it I want to find? I want to find this height. Once I find that height, I add 2 and I have the answer to the height of the whole mountain. Now, yes, we can go along and just start solving everything, but I don't recommend just going at this like randomly, because what'll happen is you'll end up with way too much information. There's information you don't need to find. So you kind of want to think it out a little bit. All right. So the only real information I'm given is that side, and the degrees is 35 degrees of that angle, right?
Mhm.
So what do I want to do? I want to think it through, and I don't know the height, but I don't know really anything else. So let's just make a triangle. And I'm going to just use a triangle that looks like this, because I can't use the right triangle because I don't know this distance. So I can't use that. But I know this is 900. And I know this is 35 degrees. And I actually know what this angle is. Can you tell me what that angle is?
It would be 180 minus 47.
Exactly. So this angle right here, if I know that a straight line is 180, I'm explaining to anybody else who's watching. So if I know that that's 180 degrees and I draw a line like this and this is 47, then the other side has to be 133. Yeah, I think that's right. So I know now this angle is 133 degrees. And if I add those up, I have 168. So this up here is 12 degrees, right?
Mhm.
Okay, great. So what do I want to find? I literally, if I find, here, let me use a highlighter. So if I find this side. And what else do I want to find? Actually, I don't even, let me say that again. I don't even actually need that side. What I really need is this side, because I know the number of degrees here, and I know that this is 90 degrees. So I already know what this is, right?
Mhm.
So that's what 90 is 137. So this is 43 degrees. So if I find that line that I've highlighted, which is the same as this, I have really everything I need to find the height. Do you see that?
Yeah, yeah.
Okay, so what I'm trying to say is first figure out what you need, because I originally said we needed the other side and I have no use for that other side, honestly. So I could find it, but what would be the point? Okay, so let's name these. I'll call this ABC, and that means this is C, B, A. What I really want to find is A, and I know C. So I can use the sine of C over C is equal to the sine of A over A. And the sine of C is 12 degrees over 900 is equal to the sine of A, which is 35, over A, which is what I'm trying to find. So A here is going to equal 900 times the sine of 35 degrees divided by the sine of 12 degrees. And then we need our calculator. So sine of 35 times 900 divided by the sine of 12 equals, so A equals 2,482.8. Let's just say 283. I mean, for that, I mean, for the size of it, I think we can use to the nearest integer. And that would be 3. Okay, so now I know A is equal to 2483. And if I just pull that triangle out, I literally have a right triangle where this is 2483. This is 47 degrees. This is 43 degrees. And this is a right triangle. Now, do I need to use the law of sines again to find, because what am I trying to find? I'm trying to find H. So do I need to use the law of sines here?
Mm, I would say yes.
Okay, and I'm going to say no.
Okay.
And you could use the law of sines. I'm not saying you couldn't, but but we already know everything we need to know about right triangles in a much simpler way, right? Because this is a right triangle here. So I know that the sine of 47 degrees is going to equal opposite over hypotenuse. And that's really what I know. I already know that from all the trig we've had before.
Gotcha.
And
Okay.
we actually don't need to ever use the law of sines for a right triangle.
Okay.
That's like, so the law of sines is really there for non-right triangles. Will it work with a right triangle? Of course it will, because here, if I use this as, say, C, what's the sine of 90 degrees?
That is 0. Sorry, one. Yeah, go
Right.
ahead.
So like, if I have sine of A over A equals, just for example, sine of B over B, I can also flip them, right?
Yeah.
That's the same as A over sine of A equals B over sine of B, right?
Right.
Well, if one of these is 90 degrees, it's just one. So again, there's really no reason for me to use it. If I have everything else, which is what I really have, I don't need to do it. I can use my sine equals opposite over hypotenuse, my cosine equals adjacent, and so on and so on. Okay.
Yep.
So now this is pretty easy. I know that H is going to equal 2,483 times the sine of 47 degrees. And again, that is just a calculator problem. So 47 degrees sine times 2,483 equals, so I get the height is equal to 1,816 feet. But don't forget, we always have to add this 2. So it would be H equals 18 feet altogether. Or the height of the mountain, not H, but I guess I should say the height of the mountain. So H mountain. Okay. And that's really all, that's pretty much everything. So when do you use the law of sines? When you don't have a right triangle. If you have a right triangle, it's just extra work to use the law of sines. It will work, but it's more work than necessary. And that really concludes everything from the law of sines. I don't have really anything else to offer. I can answer any questions if anything didn't make sense. I have one more problem I can do if you want me to do it. Otherwise, we're kind of done.
I'm good. I don't have any questions. It was extremely straightforward. Probably the easiest thing up until now.
Yeah, this is really straightforward. The only thing that's not straightforward